Hey guys, just thought I would give you a quick update on how the progress is going with the Blackhorse Viper build. Uh, I'm doing the install for the heartbeat of this plane, the power system. So I'm doing Wemotec 100. This plane calls for a 120, but I'm doing the 100 just to get more speed as opposed to thrust. So, some of the challenges that I've come across doing this. I'm just going to give you a view from the cockpit, or the battery area, I should say. Hopefully you can see this all right. Apologize for the shakiness. But because of the size of this PLA 3D printed intake ring, there is obviously the battery floor here, and right about here is where there's another tray, right? And that is for all your receivers and additional electronics there. That's the tray there. Gives you a better view of it. So the intake ring is too big to pass this area. So if you wanted to install your thrust tube and everything all together outside of the plane and then pass it through this frontal area all the way to the back, the intake ring won't pass through. So how to fix that? All right, so we'll talk about this really quick. So PLA printed air intake ring, PLA printed coupler between the intake ring and the motor. Okay. Thank you, Warcheck, for sending me the files so that I could do this. Please check out his YouTube channel. Guy's got a ton of knowledge and really helpful. Anyways, quick little thing about this intake ring. On the inside of the intake ring, it's actually stepped down, and primarily the step down is for the fan side of the intake ring. So the problem being that when you try to slide it over this side, it doesn't fit properly. So what you have to do is just grind it down so you've got a fairly good transition between this side and this side. Okay. The other thing that I did too as well was after I did that, I put them both together, right? Because I wanted to just do a test because it's very, very tight. It's a very tight fit, right? So I wanted to do a test just to see if I was to put it together and then just shake it a bit, is the intake ring going to come off with the motor, or is the motor going to fall off and the intake ring is going to stay on, or sorry, the coupler, I should say. When I shake it with a dry fit, is the coupler going to stay on the 3D printed intake ring, or is it going to stay on the EDF after shaking it and it comes apart? So just trying to figure out where is the largest amount of force from a vertical movement, right? Up and down. Trying to, I guess, mimic a hard landing, if you will. So it should be pretty obvious, but you've got all this motor back here, which is like 300 and some odd grams or whatever it is, 500 grams, I can't remember. It would make more sense that this is going to be falling off. The motor obviously is going to fall off, but the intake ring actually stayed on the PLA. So the motor will fall off and the intake ring stays here. So what I decided to do was, I thought, you know what? On this side, if you can see this little line here that I drew, just as an example, on the right side of the line, I thought what I'd do is I'd use epoxy, so a two-part epoxy, to glue the coupler to the intake ring. And then on the left side, I would use a flexible adhesive like Permatex to glue the fan to the intake ring. So that way, like I said, if I get any vertical movement from a hard landing, you have an adhesive that has a little bit of give, as opposed to on the right side where there's less weight, you have an adhesive that has a tendency to crack and be brittle. Okay, So that was the rationale behind that. I know I spent a bit of time to explain that, but I think that's also really important if you are going to go this route with this model. And there goes a notification. All right. Now, now that we've got that part done, so once you've glued this together, and the way that I glued this was I glued, like I said, glued the intake ring onto the coupler first with the epoxy, let that sit for 24 hours. Then I wrapped some tape on the inside of the intake ring. Then scored a little bit of the edge of the EDF plastic mount. And wrapped the outer edge here with some painter's tape, and then put the Permatex on this, as opposed to this being the EDF, obviously, as opposed to putting the Permatex inside the intake ring. Reason being because when you're pushing these two together, it'll squeeze the excess Permatex out this way as opposed to push it in this way. And then that way you get a glob of crap close to your blades throwing off your weight, which you don't want to do. So make sure you do it that way, that you put the glue on here, put it together, rather than on the coupler itself. Okay, so you do that, set it aside, and let it set. So like I said, epoxy, 24 hours, then fan attached, another 24 hours. And let it sit. Next, you turn around and you install your exhaust tube. So put it in the plane, run your wires up in it, and then push it further back into the plane. And then put the intake ring and the motor in to the plane, and then bring them together, right? Obviously, I'll just tape that, but that's the only way that you can do it because of how far back this motor is going to be pushed. Because this here is where the normal 120 mountings are, but this motor is a bit lighter than a 120 as well. So, in order to get the CG properly, this needs to sit further back, down around here. Now, the added bonus for it to sit here as opposed to sitting up here is that the amount of thrust that's going out this way has a shorter distance to travel to exit the plane, so therefore less drag on the thrust that's going out. Less drag, better efficiency, more speed is the whole idea. Hopefully that all works out well. I mean, I've seen Warcheck's results, and they've been pretty impressive. Okay, so that's it. I realize it's a bit of a long video, a lot of explanations and so on, but I thought I would just do this because I don't think anyone has. And honestly, guys, it's a bit more involved than I thought it would be. To be honest with you, there's a lot of dry fitting prep work that you have to do to get everything as best you can. The other thing too is the best FSA for the 100 millimeter Wemotec is, I believe, 85 millimeters exit diameter. And a really easy way that I was able to do this was I actually found a can. I think it was a can of beans or something that was exactly 85 millimeters. So I just wrapped my thrust tube around that, or wrapped my what the hell is it called, mylar around that to make sure I had the perfect diameter for the exit. So worked out, and that's really about it. So anyways, hope your builds are going well, and talk to you soon. Houston out.